Hi, in this video I'm going to talk about the different types of variables or data that you will come across and how do you deal with those variables while doing univariate data analysis, and we'll learn that in the context of survey data. So why do we get survey data? We get it while doing social science research, when we do market research, or maybe the government agency is doing policy research, also try to get data by doing survey. Survey can be done in various way. It used to be done face to face manner. People used to go and collect data. Still people do it, but because of the availability of modern technology, then this has changed. We can do it now with email, with mobile, with different forms of social media. You can also do it with specialized softwares like CRM softwares. You can get some softwares like Survey Monkey. This modern software you can do survey very easily. So get data through these sort of ways, and then when you get data you will get it in various forms, and we'll talk about the forms of the data, and then we'll see how we can handle the data before we can use the data for analysis. So when you get variables or data that you get, could be, let's say, somebody's weight, somebody's education, income, right? In social science research, these are important variables. So these variables could be of various types. One type could be the continuous variable. It's always numerical in nature, and it can be a positive or a negative number, and the examples could be age, weight, temperature, and so on. So why it's continuous? Because it can take any value, just any value. Okay, education could be, let's say you have 12 years of education, 15 years of education, and so on. Income could be anything, right? Some variables can be negative and positive both. Some variables have to be positive, like weight cannot be negative. Okay, but income can be negative, because if somebody is in debt and is paying interest, then the net income would be in negative, right? If it is, the payable is more than the receivable, then it's a negative income. You can also get categorical variables, which could be of various types, could be ordinal, nominal, dichotomous. So what is ordinal variable? So a categorical variable, so categorical means it's not continuous. Okay, so it could not be numeric. Categorical means various categories are given, like male and female. Somebody's gender is a categorical variable because it takes only two values, male and female. So such data is considered to be categorical, which has got some categories. Now, among these categorical variables, we can also get ordinal variable, nominal variable, and dichotomous. What is ordinal variable? Well, ordinal variable is a category in which the different types of the category can be ordered. So we'll take an example to understand. For instance, somebody's education. So the order could be low education, slightly more, then more education, and the most education. That means we can arrange in ascending or descending order in terms of some quantifiable measure. So no high school education, high school degree, some college degree, right? So in the order of higher education, right? This is in the order of higher education. Number of years of education increase with this order. So this is why we call this as ordinal variable, because there is some order. Similarly, the other example could be agreement. You are strongly disagreeing on something, you are disagreeing, you are neutral, you are agreeing, and you are strongly agreeing on something. So we can see some order, right? From strongly disagree to strongly agree. Rating of something: excellent, good, fair, poor. You're rating sportsmen or celebrities, you can give it rating some sort of. It can be numbers also, 1, 2, 3, and 4. or you can say, it's poor, it is fair, it is good, and excellent. Okay, so that's why we call these as ordinary variable, because we can order in some fashion. Nominal variables. So categorical variables without an order are called nominal variables. An example of nominal variables could be, let's say, somebody's demographic. Somebody lives in northwest of US, south of US, middle west of US. We cannot order, right? We cannot quantify somebody's state or somebody's demographic. Similarly, sex. It could be male and female, right? It cannot be, let's say, quantified. Nationality, American, Mexican, French, they are all values which cannot be put it into orders. So these are examples of nominal variables. Dichotomous variable. So dichotomous variable is where you get just two values. Let's say you get an answer yes or no. When you do a survey, many times you will have this question asked to them that do you agree on something. It could be only two, it could be having only two options, yes or no. You cannot have a third option. In that case, if it has only two options, then we call that as a dichotomous. The dicho itself means only two, right? So yeah, so dichotomous variables are something where you get only two categories, yes or no. And dichotomous variables can be ordinal or nominal, okay, depending on what the variable is. Coding, it's an important part of when you get your data through surveys. You cannot directly use them. You have to transform them before they are usable. Why is it necessary? So let's look at it. Well, you get a data called, let's say, gender. Somebody's gender is male and somebody's gender is female. So coding actually transform the data in such a way that you can then use them. Okay, so you can use short form of the same. Let's say male can be written as just M. A female could be only female. Now if you just write M or F, it is very difficult to understand. So you transform that into male and female. And this could be a simple example. But most of the times we need that in some sort of numerical form, because in order to use this data in software, you need to transform them into some sort of a numerical forms. So if, let's say, for example, somebody has given this answer that he agrees on something and he doesn't agree on something. If the answer is no, then let's say we code it as 0. If the answer is yes, then we code it as 1. Now we have replaced no with 0 and yes with 1, and we keep that in a dictionary, data dictionary, so that we can use that later on. But what it helps, the way it helps is that since there are two values which are numeric, so which is dichotomous variable, it can well be used without having issues where the data cannot be some sort of a non-numeric type. Okay, so data dictionary is important. That's one important point, because later on if somebody else is going to use, then he need not be confused as to whether 0 is yes or 0 is no. Okay, so that clear definition should be well maintained. Okay, so let's understand what is dummy variables. Oftentimes this will come across this term. So this is a variable which is coded, which is basically derived from a dichotomous variable. From a dichotomous variable you derive a dummy variable. So cases where you just have two values, two levels. Okay, it could be yes or no, male or female. Okay, so dummy coding is always done for dichotomous variable, and the reason why I do it is because we need to know some sort of a numerical form of it, and for comparison purpose. So in many data analysis you need to compare the effect of two two groups of data. Okay, So you need that in numerical form. Let's say you said we decode male as 1 and female as 0. Now we have coded into numerical forms, and that can well be used. And this is called dummy value. And dummy takes only uh, two data points. Sorry, two values. So dummy variables always take two values. How do we code ordinal variable? Well, ordinal variable should be coded in such a way that the order is maintained. Okay, you remember that example we took. Did not graduate from high school graduate, some college and college, right? There is some order, right? Increasing order of higher education. Now, when we coded it into 0, 1, 2, 3, the proper code, because the ascending order has been maintained from 0 to 3. It's a perfect ascending order. You cannot just code this as 2 and code this third one as 1. You cannot make it 0, 2, 1, 3. Then that will be wrong, because in that case the order has not been maintained. Nominal variables. For nominal variable, the order need not be maintained, right? When you code, you can just use any number as per your convenience without having to maintain the order, unlike the previous one where you had to maintain a strict order of either ascending order or descending order. Continuous variables. The continuous variables sometimes we use directly, and sometimes we transform them into different code and then we use. Okay. So one example could be, let's say, income. So income is mostly a continuous variable. We get, let's say, somebody's $20,000, somebody's income is $30,000, and so on. But we can make it, let's say, dichotomous or ordinal or nominal based on what the requirement is. Let's, for instance, we say that it can have two categories: high income and low income. We make it a more of a dichotomous type: high income and low income. Okay, so how do we get to know that? With a threshold. Income greater than, let's say, $50,000 belongs to high income group, otherwise low income group. Okay, so that's one way of coding your continuous data into some sort of a non-continuous data, right? So instead of the actual value of income, now we'll have just 1 and 0. So it becomes a dummy variable now. Data cleaning. So one of the first step in analyzing data is to clean your data. So what are the ways you can clean your data? Well, first you need to see if there is presence of outliers. So really high or low numbers should be removed from your data. For instance, if somebody's age is, let's say, 110, it cannot be 110, right? It could be an erroneous data. It could be just somebody's age is 10 and 11 and it has been clubbed together so that it looks like it's 110. But when you do survey, and somebody who has done a survey might have made an error while taking down the data point, so that could be an issue. Sometimes you have data for which there is no value, that for instance somebody's gender, so it could be the male or female, but let's say we have data which is 2, so either it's not 0 or 1, it's 2. That is not part of the survey, right? We do not consider anything other than 0, 1, 1. So that is an outlier data or an extreme data which should be removed. Missing values. Many times you will have data where there is no data as such, but something accidentally was entered in the database. So that will cause issue or an erroneous analysis. So that has to be removed. Some data has a limit already defined, and it cannot be greater or less than some interval. Okay, let's say somebody's probability. Probability always lie between 0 and 1, right? Um, so if somebody's probability of something, let's say, is in negative number greater than 1, then that's the wrong data. It has to be rechecked. If in case it's wrong, then it should be deleted. There could be issues in date formats and so on. So formatting checks are quite important also. Sometimes your date could be because in date data could be of a different format, right? And in different countries you will find the way we write the dates are quite different, right? Sometimes we start with DD, month first and then date, but sometimes we also write day first and then month. So there should not be any confusion, has to be very clear. Sometimes there is double entry, the same data has been entered twice, so it get inflated, and that should be carefully should be dealt. Once we have this clarity of having a categorization of what kind of data we are having, then we know what type of coding that is to be done, and then we have cleaned the data, then we can start with some sort of a summary statistics. So summary statistics, when we talk about summary statistics, the most popular ones are like, start with mean, which is average, median, we take the just variation of data, right? And then you take more, like what is the, let's say, count of each data points in the data, so that you take the majority of them. And then range could be just the difference of minimum or maximum. Max minus minimum is your range. So all that try to gives you two thing, which is where the data is centered. So mean, median, and more would like to give you where the data is centered. That means where most of the data points are located. And your range, and then there are some other things like standard deviation, variance, okay, and skewness, kurtosis. These things will give you an idea of how well the data is distributed. So data will be distributed this way, data could be distributed in this way as well. So the distribution of the data is given by, let's say, standard deviation, variance, skewness, kurtosis, whereas where the data is centered is given by mean, median. So you can also get standard deviation. You can get different form of the distribution of the data. Just by plotting the data, you can get to know how the distribution of the data looks like. You can also get the percentile values. That also gives you an idea about how the data is distributed.